So the string of the bow and arrow will provide a force, which will, seeing that the apple is starting from rest and going to go a speed of VF, it must accelerate, as shown here.
Alright, we're going to be demonstrating some Bernoulli's effect, and we got the classic pose example for the A1V1 equals A2V2, and as Kevin turns on the water, we can see that that cannot move that apple, but when I decrease the A and increase the V, it moves. There we go. That's it.
Alright, so this apple has energy, and once you light it on fire, the energy from the apple will go into heat energy. So let's see it in action. Oh!
Alright, hold on a second. Give me the axe. Give me the axe. Oh shit. Oh man. Oh dude, the heat, I can feel it. Oh my. Let's do it again. No way.
Conservation of energy.
No, it doesn't work anymore. Whatever, it worked.
Alright, Doppler effect. So when we have a cell phone taped to an apple, and an alarm is going to go off in a couple seconds. So when the alarm goes off, sound waves will disperse everywhere like shown here. When we throw an apple one way or the other, the sound waves will compress, as shown in these pictures. Alright, so we'll see this in just a second.
Where's it gonna go?
It should go off any minute now. This is the apple with the cell phone. And once we throw it, the sound waves should be compressed. So here's the music.
I just picture it in the ringtone.
Alright, so Max is going to exert a force on the trampoline, which is going to transfer to the apple. And see that he has such a greater mass than the apple. The apple should go flying. So let's test this out.
Yeah! Awesome! That's it. Turn. Alright, we're going to demonstrate friction by testing out 3 different mu's. The first one is going to be just the cement floor. Then we're going to go outside and test the gravel and then the grass. Alright, so let's test out the cement first. And now we're going to test out the gravel, which should have a significantly higher mu. Yes. Now it's time for some grass testing, which should have the highest amount of friction.
Gravitational force. Gravitational force is represented by the equation capital G times m1 times m2 divided by r squared. Now to show this force, we're going to use my favorite apple tree, and I'm going to shake it and watch gravity do its thing. Alright, here we go.
Whoa!
And that's gravity.
Apples!
So this apple has mass, which means it has inertia. So if this slide here, this nice yellow slide, went on forever, and the apple would roll forever because it has inertia. But seeing that we do live on Earth, and there are forces on Earth, like me, to stop this apple, it won't roll forever. So let's see it. That was good.
Inertia.
Alright, so dispersion is defined as the separation of visible light into different colors. And here we have three different colored apples. We have red, which is 650 nanometers wavelength. We have yellow, which is 570 nanometers. And we have green, which is 510 nanometers. So each wavelength is each color is a different wavelength, and that's dispersion.
The apple. Shit. Alright, right here we have light and reflection. If you come in here, you'll see a little light beam coming in the apple, and you can kind of see the light beam being reflected. Alright, so we're going to move that out now. And you can see this is the angle of incident, the light that came in and hit the surface of the apple. This is the tangent line, which is where the beam is reflecting off, and this is the reflection light. So the angle of reflection from the beam of light here is equal to the angle of refraction here. Reflection.
Hi, I'm Tegan. I'm going to show you how the magnetic poles of this apple change the direction of this compass needle.
See, that's magnetism.
That's magnetism.
Mechanical advantage. Alright, so let's test mechanical advantage with Cam's crutch and an apple. Alright, so now Cam's going to push on the lever, part of the crutch, and he's not really pushing hard and pushing a good distance, but the apple doesn't travel far. Alright, so let's go to the medium one now. Cam's going to push somewhat hard, not that much. It's taking a little more effort, and it's going a good distance, not as far, and the apple is now traveling more. Now we're going to go really out. Cam really is struggling now. Doesn't push far, but it's a lot of force, and the apple moves a good distance, very far. So, the momentum, the MV from this apple, while it's falling, will hit this apple and transfer to this apple, which will then transfer to this apple and cause it to move out like this. Okay? So, let's see it go. So that's one angle. This is another way. Okay. Go. Alright, so now we're going to pull both apples back, and the MV from this apple is going to go this way, transfer through the center apple, while this apple is going to go travel through this way and travel through the center apple, and they should both pop out like that. Alright, so let's see it go. 1, 2, 3.
Wow, that was good.